Hello students, welcome to the YouTube channel of Padmabodh. The topic that we are going to cover today is ray optics. It is a very interesting chapter and my personal favorite, and by the end of the series of this chapter I'm pretty sure it is going to become very easy for you. If you are someone who had problem in understanding this in 10th grade, then this will be a very helpful video for you. So let us start. So what is ray optics? So ray optics is the branch of physics which deals with the particle nature of light. So first of all, what is light? So the electromagnetic radiation with wavelengths in the range about 4000 angstrom to 7500 angstrom, to which the eye is sensitive, which means which we can see, is called light. Now let us understand the laws of reflection of light. So when light falls on the interface of two different media, three phenomena occur. First is reflection, second is refraction, and the third is absorption. So, reflection is, as we all know, bouncing back of light, and refraction is bending of light in the other medium, and absorption of light is, as the name suggests, that some light gets absorbed into the medium. So, we are now going to understand the laws of reflection of light, the first phenomena that takes place. The first law states that the angle of incidence is equals to the angle of reflection. When on a reflecting surface, an incident ray comes, first we will draw the normal. The normal is just an imaginary line perpendicular to the surface of reflection, and it will bounce back into the same medium, and the angle subtended by this reflected ray will be r, and these both angles will be equal. The second law states that all three of these lines are lying on the same plane, right? That is law of reflection. One more important thing to notice is that this is not just true for plane mirrors. It is also true for spherical mirrors. Let's say I have a convex mirror over here. Now when a light is incident on this convex mirror, I will try to complete the sphere of which it was once a part of. Now this is the center of that very sphere, and okay, let me just change it a bit. Let's say it is incident like this. Now, as we all know, on this surface, if I join this point with this point, I will get the normal of that surface. So here I have the normal, and now the light will bounce back at the same angle. If this is theta, then this is also theta. So it is also true for spherical surfaces. Now we know that there are two types of mirrors. There are plane mirrors and there are spherical mirrors. So we are going to dive deeper into the theory of plane mirrors now. So the first point that I have noted down here is that the object distance and the image distance are equal and opposite in case of mirrors, which means that if I have a mirror over here and if this is you standing over here, then if this distance is, let's say, 1 meter, then this distance of your image will also be 1 meter. I think you might have noted this yourself, that when you get closer to the mirror, you get like your image also gets closer, and when you get farther away from the mirror, your image also gets farther away, and it seems to be very much of equal distance. Now the second point is that it is kind of the further explanation of the first point, that when I say that the distance is equal, I mean that the perpendicular distance is equal. Let us understand this through two cases. So let's say that I am standing over here, or this is the object that is here. Now this perpendicular distance will be equal to this perpendicular distance. But if the mirror is tilted like this and the object is kept over here, now as you can see, I cannot just say that, yeah, I'll just draw a straight line and then look this and this is equal. No, that's not correct. The perpendicular distance is equal. So this is right and this is wrong, because this is not the perpendicular distance, this is the perpendicular distance. Let's now take into the look to see how we draw the ray diagram in a plane mirror of a point object. So here I have made the final diagram, and here I am going to show you the step-by-step procedure to make the diagram. So here I have my mirror. Here I have the object. Now the first thing that we have learned is that this is how I like to remember it, and you can also do the same. So the first thing that we know is that the image and the object distance are equal, their perpendicular distances are equal. So first I'm going to draw the perpendicular of this object onto the surface, and with equal distance I'm going to draw the image on this side. Now roughly I have done this so that it can be easier for me to make the ray diagram. Now what you have to do is that you have to throw a parallel beam of light at the mirror. Now whenever you see an incident light on a plane mirror, the first thing you do is you draw a normal at the very surface on which it has fallen, and then draw the reflected ray. So this is the incident ray and this is the reflected ray. This both angle are equal. Now we are going to extend this line backwards for our understanding. So just extend it backwards. Now as you can see, it is not the exact same, but it did help me to make the diagram. So you go like this and then you join it with this, and here will be my image. This distance will be D and this distance will also be D. That is how I made this diagram. So in this diagram, the object here is real. It is a real object because it is on the reflecting side of the mirror. And the image here is the virtual image because it is on the back side of the mirror. It is not actual, there is nothing actually there. It is a virtual image because it is on the silvered side of the mirror.